Good day to you. I'm welcoming you again to my chemistry class, and I am going to treat the final part of pH and pOH of solutions today. In the first part of this topic, I was able to give some formula that will be used in calculating pH and pOH of a given solution. So today we want to have a look at different examples on the calculation of pH and pOH. All right. Now, this is my first question. What is the pH, pOH? Hydroxyl ion concentration and hydrogen ion concentration of the solution 0.02 mole per dm cube sodium hydroxide. First and foremost, you need to identify what type of solution sodium hydroxide is. Yes, of course, sodium hydroxide is a base. That means this concentration you are given here is nothing but what? P, that is the hydroxyl ion concentration of this solution, because this is a base. So I am going to write this in form of ions, the sodium ion and the hydroxyl ion. So there's an invisible one here. There's an invisible one here. That means this is 1 mole. 1 mole of hydroxyl ion. So, since it is 1 mole of hydroxyl ion, that means to answer this question, finding the, because I told you, and rather I mentioned it in my first video, that when you see a square box with an ion inside of it, the square box represents concentration. So that means the hydroxyl ion concentration of this base is 0.02 mole per dm cube, which I will advise to convert to standard form. That will be 2 times 10 raised to power minus 2 mole per dm cube. I have answered this question. Now, what X can I find with this? I can use this one to get the hydrogen ion concentration. And I can also use this one to get the pOH. But I cannot use this one to get the pOH, because pOH can only be found using hydroxyl ion concentration. And pH can be found only using what? Hydrogen ion concentration. So let me find the hydrogen ion concentration first. So to find hydrogen ion concentration, remember in my formula, in the formula rather I wrote in the last video, hydrogen ion concentration multiplied by hydroxyl ion concentration will give us 10 raised to power minus 14. So it's in the last video. That is the first part of this topic. Okay. Now, let's apply our knowledge of mathematics. This 2 times 10 to the power minus 2 will replace this. That means hydrogen ion concentration times 2 times 10 to the power minus 2 equals to 10 to the power minus 14. Dividing both sides by this, by 2 times 10 to the power minus 2. So, what would that give us? This will cancel this. That means hydrogen ion concentration equals to, by the time you divide this one, that will be 0.5 times 10 raised to the power minus 12, which is the same thing as 5 times 10 raised to the power minus 13. Now that I have both hydrogen ion concentration and hydroxyl ion concentration, I can now go ahead and find pH and pOH. Now, what is the formula for pH value? That is minus logarithm for the hydrogen ion concentration to base 10. So definitely that will be equals to minus logarithm of this value, 5 times 10 raised to power minus 13 to base 10. According to the law of logarithms, this multiplication will change to addition. Then this 5 and this 10 raised to power minus 13 will go with separate logs. But don't forget this negative is affecting all of them. So I will put the negative outside. Then that will now be log 5 to base 10. This multiplication changes to plus. Then another log 10 raised to power minus 13 to base 10. Okay. So what next? Still applying law of logarithm. That will be negative open bracket log 5 to base 10. According to the law of logarithm, this minus 13 will shift here and it's going to multiply this plus. That will now give us minus 13 log 10 base 10. That will be minus to bracket log 5 base 10, then minus 13. Why? Because log 10 base 10 will be equals to 1. That is one of the laws of logarithm. Okay? So the next thing is to find the value of log 5. What is the value of log 5? Log 5 is 0.699, then minus 13. That will be negative into bracket 0.699 minus 13 will give us minus 12.301. But the negative outside will multiply the negative inside. That will be positive 12.30 approximately. So that means this is a pH. How do I now find pOH? I can find pOH in two different ways, which I'm going to show you now. The first way and the shorter way and faster way is to apply this one of the formulae I mentioned in my first video on this topic, that pH plus pOH equals to 14. Why is this faster? Since I've known pH, I will just subtract it from what? 14 to get pOH. And if I knew pOH, I will just subtract it from 14 to get pH. It's as simple as that. So now that means pH, which is 12.30 plus pOH equals to 14. So pOH will be equals to 14. This will cross to the other side because minus 12.30. And that will give us what? 14 minus 12.30. That will give us 1.70. That is the pOH. Alternatively, you use a formula for pOH, but that will take a longer time. That's minus logarithm of hydroxyl ion concentration to base 10. And that will be minus logarithm of 2 times 10 to the power minus 2 to base 10, because that's the hydroxyl ion. I mean concentration, yes. So that means we are going to have minus log into bracket, minus into bracket, or log into bracket, log, that will be minus into bracket log 2. This will change to plus, then log 10 to the power minus 2. So that will be minus into bracket. This is 0.3010 minus 2, because this one will come here to become minus 2, and log 10 base 10 will be 1. So that will be minus into bracket this minus 2. That will give us minus 1.70. So minus times minus will be plus. That's 1.70, which is the same thing as this. This is another question. We have to find the pH of the solution containing 0.01 mole per dm cube calcium hydroxide. This is a base. That means this is hydroxyl ion concentration. Okay, so first thing, write this one in, break it down into ions. It's very important. That will give us calcium 2 plus 2 OH ion. So definitely, since there are 2 moles here, this is 2 moles. That means concentration, the hydroxyl ion concentration will not be 0.01. It will not be 0.01 times these 2, because there are 2 moles here. And that will be 0.02, which is 2 times 10 to the power minus 2 mole per dm cube. So this is the value we are going to use now to find pH. But like I told you, this is hydroxyl ion concentration. So I need to use this one to find pOH. It is now pOH I will use to get pH. I cannot use this one to find pH because this is hydroxyl ion concentration, not hydrogen ion concentration. So to find pOH, that will be minus logarithm of the hydroxyl ion concentration, which is 2 times 10 to the power minus 2. That will give us minus open bracket log 2 times, here we change to plus according to log logarithm, then log 10 raised to the power minus 2 to base 10. So that will be minus into bracket, this is 0.3010 minus 2, because when minus 2 comes there, this one becomes log 10 base 10 becomes 1, and that will give us minus into bracket 1.70 negative, sorry. Oh, when minus multiply minus, that will be plus. That means pOH is 1.70. Now, how do I now get pH from here? It's very simple. Now, since pOH is 1.70 mole per dm cube, I will just use this approach. pOH plus pH equals to 14. So definitely pOH is 1.70 plus pH rather, equals to 14. This one will cross here, so pH will be equals to 14 minus 1.70, which is 12.30 mole per dm cube. So some people who might not know this approach will go and be finding hydrogen ion concentration first before they can find pH. That's a longer process. Please take note of this. Let's have a look at one more example. All right, this is another example question. We are to calculate the pH and pOH of the solution containing 0.0002 mole per dm cube solution of this acid, which is a phosphate acid, tetraoxophosphate 5 acid. Okay, first thing, you have to break it down into ions. That is dissociation. That will be 3 hydrogen ion plus 3 minus. Now, this is 3 moles of hydrogen. 3 moles of hydrogen ion. That means hydrogen ion concentration rather that we are going to use will now be 0.0002 times 3. and that will be 0.0006 mole per dm cube. So let me change it to standard form. That will be 6 times 10 raised to power minus 4 mole per dm cube. Alright, since I've known hydrogen ion concentration, this is hydrogen ion concentration because this is an acid, it's not a base this time around. So if it were a base, that means it could have been hydroxyl ion concentration. Take note of that. So that means I can find pH. pH will now be minus logarithm of this concentration, which is hydrogen ion concentration. And that will be pH will be minus logarithm of 6 times 10 raised to power minus 4. So that will be minus into bracket log 6 plus log 10 raised to power minus 4, 4 to base 10. Okay, we have done many examples on this, similar to this before. Now, we find the log of 6. And what will be log of 6? So, log of 6 is 0.7782. Then minus 4. Because this minus 4 will come here. Minus times plus will give us negative. And log 10 base 10 is 1. Alright, that will be minus into bracket 0.7782 minus 4 will give us negative negative 3.2218. Negative and negative will give us plus. So that means pH equals to positive 3.2218. Let's approximate to 3.22. That is the pH. Now, to find pOH, pOH plus pH equals 14. So that means pOH plus 3.22, this one will replace this, equals to 14. So pOH will be 14 minus 3.22. When this one crosses here, it becomes that. So the final answer for pOH is 10.78. Now, let us now ask ourselves one question, which I want you to think of. pH is 3.22. pOH is 10.78. If they ask you, is the solution strongly acidic or strongly alkaline, what will be your answer? The solution is strongly acidic because 3.22 is far away from 7, which is neutral. Okay? And considering this one, 10.78, that means is closer, this one is closer to 7 because the difference between this one and this one is 3.7 and the 7 is 3.78. So that means this one is 3.78 from 7, which is farther away. That means it's also but this one is 3.78 also from 7. So the solution is both strongly acidic and basic because both of them are far away from 7, which is neutral on the pH scale. So take note of that. So this is the end of calculation on pH and pOH. In my next video, I will be treating salt. Do not miss it. Thank you.